The other special right triangle is a 30, 60, 90 triangle. So what that means is each of the angles in the right triangle are 30 degrees, 60 degrees, and 90 degrees. And then if I use a baseline triangle, like I did with the 45, 45, 90 triangle, it's 1, 2, square root 3. If you remember back to triangle inequalities, the shortest side in this right triangle has to be this side, the side opposite the smallest angle, the 30-degree angle. This is the middle side, this is the longest side. And then for your 30, 60, 90 triangles, the shortest side is 1. The longest side is actually 2. 2 is more than the square root of 3, so the longest side has to be the hypotenuse. And then the side opposite the 60 is the square root of 3. I could use that if I'm setting up proportions to find missing sides of a 30, 60, 90 triangle. Or here's another way that you could set it up. If this is 30 degrees, this is 60 degrees. The easiest thing to do is base everything off the side opposite the 30-degree angle. I'm going to let that be x. The hypotenuse is twice as long as that, so 2x. The side opposite the 60-degree angle, or the longer leg, is square root 3 times the side opposite the shorter leg, opposite the 30-degree angle. So that would be x square root 3. And then I'll write down the 30, 60, 90 triangle theorem in words. So in your 30, 60, 90 triangles, we really base everything off of the shorter leg, or the shorter leg is the side opposite the 30-degree angle. So the hypotenuse is twice as long as that. And then the side opposite the 60-degree angle, which is also referred to as the longer leg, is square root 3 times that. And then we'll take a look at some examples as well. So if we kind of level the problems on order of difficulty, I would think the easiest level of problems for a 30, 60, 90 triangle is if you're given the side opposite the 30-degree angle, or in other words, that's being given the shorter leg. So I want to find the values of x and y. X is the hypotenuse using the 30, 60, 90 triangle theorem. The hypotenuse is twice as long as the shorter leg. Again, this is a shorter leg, so x would equal 2 times 12, 24. And then y, the longer leg, even though I was only given a 30-degree angle here, this has to be 60 degrees, but the longer leg is square root 3 times as long as the shorter leg. So 12 square root 3, and then you just leave it like that. Those are finding the values of x and y in your 30, 60, 90 triangle. That's what I would consider like the level 1 problem if you're given the side opposite the 30-degree angle. And then what I would consider a level 2 problem is in a 30, 60, 90 triangle if you're given a hypotenuse. Let me label these. I want to find the values of x and y. I would think for most people it would be easier to find the side opposite the 30-degree angle first, because if the hypotenuse is twice as long as the shorter leg, then the shorter leg is half as big as the hypotenuse. So take half of 24, 12. And then it's really kind of the same as the last problem. Maybe I should have picked different numbers. But if y is the side opposite the 60-degree angle, it's a longer leg, it's square root 3 times the shorter leg. So 12 square root 3. Let me pick a different example using the same triangle. Let's just say that the hypotenuse now is 40. Then again, it would be easier to find first the side opposite this 30-degree angle. It's half the hypotenuse, so that would be 20. The side opposite the 60-degree angle, even though I didn't label it yet in my triangle, now I just did, is square root 3 times the shorter leg. So 20 times the square root of 3. That's what I would consider a level 2 problem. And then what I would consider a level 3 problem is example 3. Maybe the most difficult out of the 3, because now we're given the side opposite the 60-degree angle. That's a longer leg. Okay, recall that the side opposite the 60-degree angle is root 3 times as big as the shorter leg. So if we're given the shorter leg or the side opposite the 30-degree angle, let me call that x, and this is y. If we were given this, we would multiply by the square root of 3 to get the side opposite the 60-degree angle. So do the opposite of that to get the shorter leg. 9 divided by the square root of 3 is the opposite of multiplying by the square root of 3. But just like with our 45, 45, 90 triangles, I need to simplify that radical. I can't leave the square root of 3 in the denominator. So I would multiply both the numerator and denominator by the square root of 3. In the numerator, it's 9 root 3. Denominator, the square root of 3 times the square root of 3 is 9, but then you would need to take the square root, which is 3. And if you think, sweet, okay, I remember how to rationalize the denominator, now I'm done. You're actually not quite done yet. Okay, 9 is outside of the radical, so is 3. 9's in the numerator, 3's in the denominator. You can simplify that fraction. 3 square root 3 is what it would end up being. So that's x, the short leg, or the side opposite the 30-degree angle. We still need to find y, the hypotenuse. So since the side opposite the 30-degree angle, the short leg is 3 square root 3. To find the hypotenuse, we multiply this by 2. The hypotenuse is twice as long as the short leg. So 2 times square root 3, 3 square root 3. You can only multiply the 2 by the 3 outside of the radical. 2 times 3, 6. And then we still have the square root of 3. That's, again, what I would consider a level 3 problem.